For VMware ESXi hosts to be able to connect to NFS or iSCSI storage, they need to have an IP address. That is configured on a VMkernel port on each of the ESXi hosts. So that's really the first thing that you need to do to set up storage in VMware, and I'll show you how to do it with a lab demo here. You can see my lab topology here. I've got a couple of ESXi hosts, that's ESXi1 and ESXi2. And both of the hosts have got 6 network cards. The first 2 network cards, that's VMNIC 0 and VMNIC 1, are used for management. VMNIC 4 and VMNIC 5 are used for our virtual machine traffic. And that's leaving VMNIC 2 and VMNIC 3 for storage. With the configuration here, you can use either a virtual standard switch or you can use the virtual distributed switch. Both are valid ways of doing it. I'm going to use the VDS, the virtual distributed switch, because that's going to allow me to configure both ESXi1 and ESXi2 at the same time. If you use the virtual standard switch, you can only configure your hosts one at a time because a virtual standard switch is tied to a particular ESXi host. So in this lab demo, I'm going to configure a dedicated virtual distributed switch for storage, which is going to be using VMNICs 2 and 3. You could have just one VDS which was connected to all of the different ports, and then you could use your more granular configuration to control which VMNICs which traffic was going out of, but I just find it a bit more logical and simpler if I split it into different switches. So my management switch and my virtual machine switch are already done. In this lab demo, first thing I'm going to do is configure a new virtual distributed switch dedicated for storage using the VMNIC 2 and VMNIC 3 uplinks. Okay, the next thing is, it is best practice that your ESXi hosts are connected directly to their storage using the same IP subnet. So your storage traffic from the hosts to the storage system should not be going through a router. So you want to have both your hosts and your storage system using IP addresses in the same IP subnet. Typically, you're going to be using one storage protocol for your storage traffic. So you're going to be using either NFS or iSCSI or Fiber Channel. For this lab demo, I want to show you how to configure both NFS and iSCSI. So I'm going to be using both, but real world, you would choose one or the other. Because I am using both, I'm going to put them both on different subnets. So NFS is going to use IP subnet 172.23.11.0/24, and iSCSI is going to use IP subnet 172.23.12.0/24. When you configure your networking for the storage traffic, there's a few different ways that you can do it. So as I was saying earlier, you can use either the virtual standard switch or you can use the virtual distributed switch. They are both valid. Also, for the NFS traffic, I could configure 2 separate IP addresses, one using one uplink and one using the other uplink. And those 2 different IP addresses, I could put them in 2 different IP subnets. As long, again, as the IP subnet matches on both sides, on the host side and on the storage system side, that is okay. I'm not going to do that. I'm going to do it the most simple way possible. So I'm going to just configure one IP address on the host. What's important is that the traffic is able to take advantage of redundancy and load balancing. So the traffic, your NFS traffic and the iSCSI traffic, they have to be able to use both paths, and they also need to be able to fail over to the other path if one of the paths goes down. So as long as your solution supports the redundancy and the load balancing, there's a few different ways you can do it. Doesn't really matter which way you do it, as long as you've got the redundancy and the load balancing there. So for NFS, I could have used 2 different VMkernel ports with 2 different IP addresses, either in the same subnet or in different subnets. I'm going to do it the most simple way. I'm going to just use the one VMkernel port with a single IP address there. But with that, it's going to be able to use both paths. And if either path fails, it's going to be able to use the other path. For the iSCSI traffic, because it's SAN traffic, and I want to take advantage of the multipathing, I am going to configure my 2 different VMkernel ports with the 2 IP addresses. Again, I could have had them in different IP subnets, or as I'm doing here, I'm going to have them both in the same IP subnet. Before going on to configure it, I want to show you how this would be set up in the real world. So I'm going to go onto a website here. This is at kendrickcoleman.com, and he's got some really good configuration examples. So you can see different examples here, and if I scroll down, you can see that there are loads of different ways you can set up the networking depending on your particular scenario. Couple of ones that I will show you here. This is with 6 NICs in the ESXi hosts, and you can see that the way you set it up here is on VMNIC 4 and VMNIC 5. That's the physical uplinks going out to the outside network. He's got management and vMotion and fault tolerance traffic using VMNIC 4 and VMNIC 5. So those 3 functions are going to be load balanced over those 2 uplinks. And to keep the 3 functions separate, he's got management in VLAN 50, which is in subnet 192.168.50. vMotion is in VLAN 51, which is in 192.168.51. And fault tolerance is in VLAN 55, which is 192.168.55. The actual virtual machine traffic is using 2 separate uplinks, which is VMNIC 0 and VMNIC 2, and that's going to be in dedicated VLANs for the different virtual machines that are running on those hosts. For example, maybe there's a VLAN for engineering virtual machines and a different VLAN for sales virtual machines. And then finally, he's got his iSCSI and his NFS traffic going over VMNIC 1 and VMNIC 3. And again, iSCSI and NFS is going to be in separate VLANs and IP subnets. So that's how you could do your configuration if you had 6 physical NICs in your ESXi hosts. And this used to be a pretty common configuration a few years ago. Nowadays, we're not using 1 gigabit network cards as you're seeing here. Really, the network cards in our servers are going to be 10 gigabit or faster. So that is plenty of bandwidth that we don't need to have multiple physical NICs in our hosts. We can just have 2. We want to have 2 for redundancy. And you can see with the configuration here that all of those different functions is being load balanced over just 2 physical NICs because there's enough bandwidth on those NICs to handle all of the different traffic. But the different functions are split into different IP subnets and different VLANs. So if you do want to get some idea of how this would be best configured for your particular network, you can have a look at kendrickcoleman.com. There's loads of really good examples there. Going back to our slides again, we're using VMware Workstation for the lab, which does not actually support having different VLANs over the same cards. So because of that, I'm not using VLANs. I have got VMNIC 0 and VMNIC 1 are dedicated for management traffic. VMNIC 4 and VMNIC 5 are dedicated for the virtual machine traffic. And VMNIC 2 and VMNIC 3 are dedicated for the storage traffic. I'm running both NFS and iSCSI over VMNIC 2 and VMNIC 3. They're in different IP subnets, but I don't have them split into different VLANs as well. In a real-world environment, I would also have them split into the 2 different VLANs. Okay, so that's everything I needed to tell you there. Let's get into actually configuring the ESXi hosts to support that storage traffic now. So I'm going to go on to my vSphere client here, and I want to click on the networking button here. As I said earlier, I've already configured my switches for management and for my virtual machines. I need to configure a new distributed virtual switch now for my storage traffic. So I'm going to click on my folder here, do a right click on there, and go down to distributed switch, and I'm going to create a new distributed switch. I'm going to give this the name of storage distributed switch, and click on next. And then I am using the latest version of the software, so I'll use the defaults here and click next. Then the number of uplinks. This is for each ESXi host that is using this distributed switch for the storage traffic, how many uplinks are going to be used. And as you saw in the topology diagram, I'm using 2 uplinks on both of my ESXi hosts. The rest of the settings here, I don't need a default port group, so I'm going to deselect that, and then I'm going to click on next. Then I can click on finish. And I can look down in my recent tasks here, and I'll see that being done, and I can see that it is done already. There is my storage distributed switch. So right now I've configured my distributed switch, and I've said that it's going to be using 2 uplinks. Next, I need to specify which ESXi hosts are going to be using that distributed switch and which uplinks are going to be used on those hosts. So to do that, I right-click on the distributed switch, and I'm going to click on Add and Manage Hosts. And what I want to do is add hosts to the distributed switch. So I click on Next, and then click on the Add button to add the new hosts. And I want to add both of my hosts. That's ESXi1 at 172.23.1.31 is its management address, and ESXi2 is at .32. So I select both of those and click on OK. And then I can click on Next. And then in here, you can see that on the first host, that VMNIC 0 and VMNIC 1 are connected to vSwitch 0, which is for the management network, and VMNIC 5 and VMNIC 4 are connected to my virtual machines distributed switch for the virtual machine traffic. And if I scroll down, you can see it's the same on my second host as well. So what I want to do is specify that VMNIC 2 and 3 on both hosts are going to be the 2 uplinks on this storage distributed switch. So I click on VMNIC 2 to select it, and then click on Assign Uplink. And make sure that uplink 1 is selected. So that means that uplink 1 is going to be assigned to that VMNIC. And I want that to be the same on both of my hosts. So I'm going to tick the checkbox to apply it to the rest of the hosts. And I can then click on OK. So now that I have done that, I can see that VMNIC 2 is assigned to uplink 1, and I want VMNIC 3 to be assigned to uplink 2. So I select VMNIC 3, click on Assign Uplink, and select uplink 2, and apply that to the rest of the hosts, and click on OK. So I now see that for this distributed switch, VMNIC 2 is assigned to the first uplink, VMNIC 3 is the second uplink, and that is going to be on both my first host and also my second host as well. So I can click on Next now, and I'm going to do my VMkernel adapters in a minute. Click on Next there. I don't need to migrate any of my current networking, so I can click on Next and then Finish to complete. And I can see it being done in my recent tasks there. It is now completed. So now I can click on the storage distributed switch and click on Configure, and then look at the topology. And there I can see that uplink 1 is using VMNIC 2 on both hosts, and uplink 2 is VMNIC 3 on both hosts. So that all looks good so far. So far, I've created my distributed switch, and then I have added both my hosts to the distributed switch and configured the uplinks. Next thing I need to do is to configure a distributed port group. So I right-click on my switch again, go to distributed port group, and I'm going to create a new distributed port group. I'll do this for NFS first. So I'm going to name it NFS. I'm going to have separate port groups for iSCSI for both Fabric A and Fabric B. So this one's for NFS. I'll name it NFS and click on Next. Number of ports, I need to make sure I've got enough for all the hosts in my network. In the lab, 8's probably going to be enough. I'll just bump that up a little to 32. And in a real world environment, typically you're going to be using VLANs. I'm not in my lab here, so I can leave that as none. I do need to customize the default policies configuration. If I don't do that, if I click next, it just takes me to the ready to complete page. So I'll go back, and you see when I do tick this, it gives me a lot of extra pages where I can configure more advanced settings. I need to configure my teaming and failover, so that's why I ticked that. I can click next. I'm happy with the default security settings. I click next. I don't need to configure traffic shaping, so I'll click next there. And then on the teaming and failover, I do want to make sure that this is set up correctly. So right now it defaults that both uplinks are going to be used. They're both active. For my NFS traffic, I do want to be using both uplinks. I want to load balance across them. And if one uplink fails, I want to fail over to the other one. So you can see that they're both active, so the redundancy is already built in here. If one link is being used and it fails, it will automatically use the other link. For the load balancing, I'm going to click on the drop down there, and I'm going to use route based on physical NIC load. So for my NFS traffic, it's going to use one of those uplinks. If that uplink starts to become congested, it's then going to load balance traffic over to the other link as well. So you can see here, I am configuring my redundancy and load balancing. I've got that set up, so this is all good. I will click on next. I can use the default for monitoring and for miscellaneous. I'll click next on both of those, and ready to complete, I will click on finish. And there I can see that my NFS port group has now been added to that distributed virtual switch. Next up, I need to configure the IP addresses for NFS on my hosts. I do that with a VMkernel port on both of them. So I right click on the NFS distributed port group that I just created, and then I select add VMkernel adapters, and then click on the attached host button. And I'm going to select both of my hosts because I want to have an IP address for NFS on both of them, and then click on OK. I can then click on next when I see they're both in here. And then in here, I can just accept all of the default settings. So you see in here, you've got the option to say what this VMkernel port is going to be used for. For example, vMotion, provisioning, management, etc. There's no option in here for NFS. So how do I know that this VMkernel port is going to be used for NFS? Well, the reason is that I'm going to give this VMkernel port an IP address, which is in the same IP subnet as the IP addresses for NFS on the storage system. VMware will always use a VMkernel port that is in the same IP subnet as the destination address as long as one is available. So my NFS traffic is always going to be directed to the NFS interfaces on my storage because I'm using this VMkernel port that's got a source IP address in that same subnet. This is the one that is going to be used. So I don't need to select anything in here. I can click on next. Then I say that I want to use static IPv4 settings, and I can configure the IP addresses for both .31 and .32 here, both of my ESXi hosts. So this is an advantage of using the distributed switch, that I can configure multiple hosts at the same time. So I'll go to the IPv4 address, and the subnet that is being used for NFS is 172.23.11. On my first host, I'm going to give it the IP address .581. The subnet mask is 255.255.255.0. And then when I go to click in the second host, I click on the IPv4 address. It's quite convenient. VMware, it gives me the option of the next IP address available here. Saves me typing it in, so I can just click on that. And then on the subnet mask, it's going to autofill it with, again, the same subnet mask of 255.255.255.0. I don't want to have a gateway here. For my NFS, for all my storage traffic, I want the source, that's the ESXi host, and the destination, that's the storage system, to be in the same subnet. I don't want the traffic to be going via a router, which is my gateway, so I can leave that blank, do not configure it, and click on next. And then click on finish, and I will see that getting done. And when it is completed in my topology diagram here, I can expand that out and I can see that on my first host, it's going to be using the IP address 172.23.11.51 and its VMkernel port. The second one is .52, and that's going to be using both of my uplinks. So that's everything that I needed to configure on the host for the connectivity for NFS storage. The next thing that I would need to do is go into my storage system and configure the data store on there and also connect to that data store from the host. I'll show you how to do that in the next video. Okay, so that is my host connectivity set up for NFS. I also want to configure my connectivity for iSCSI as well. So I need to configure my VMkernel ports for iSCSI next, which also need to be in my distributed port groups. So I'm going to need a distributed port group for my iSCSI Fabric A, which is going to use the first uplink, and I'm going to have a separate distributed port group for my iSCSI Fabric B, which is going to use the second uplink. So let's create those now. So I'll right click on the switch again, go to distributed port group, and I'm going to create a new distributed port group. I will call this first one SAN-A for my iSCSI Fabric A traffic, and I'll give it 32 ports again, and I need to customize the default policies configuration, because again, I'm going to need to configure my teaming and failover settings. Click on next. The defaults are fine for security. I'm not configuring traffic shaping. I can click next there as well. And now on the teaming and failover, you can see that it's going to use both uplinks by default. But for the iSCSI multipathing traffic to work correctly, I want to have a separate path going over the first uplink and another path going over the second uplink. So I want to use just uplink 1 here. So I'm going to click on uplink 2 and then click on the down arrow to move uplink 2 into an unused uplink. I'm just using uplink 1 here. So load balancing, it doesn't matter what I set this to, there's only one uplink. So obviously there's going to be no load balancing here on that uplink. I'm going to use my multipathing software for the load balancing later. Okay, so I can click on next here, and I can accept the defaults for monitoring and the default for miscellaneous and the default for ready to complete, and click on finish. I'll also do my distributed port group for SAN-B now as well. So I'll right click on the switch again, go to distributed port group. It's a new distributed port group. I will call this one SAN-B and click on next. Give it 32 ports. Tick the checkbox to customize the policy. Click on next, next on security, next on traffic shaping, and for teaming and failover. So my first port group, which was Fabric A, was using uplink 1. So this one needs to use uplink 2. So I click on uplink 1 and the down arrow to move uplink 1 to the unused uplink. So Fabric B is just using uplink 2. I can then click on next and next and next, and then click on finish. So that is my port groups done. I still need to configure my VMkernel ports for host A and for host B with their IP addresses that are going to be used for iSCSI. So I right click on the SAN-A distributed port group that I just created, and I'm going to add VMkernel adapters. And then I'm going to click on the plus button to add my hosts. I want to add both host 1 and host 2. I click on OK, and then click on next. And then in here, again, as you saw when we configured NFS, there's no option here for NFS. There's also no option for iSCSI. Again, it's going to use the iSCSI VMkernel ports to connect to the iSCSI ports on the storage, because they're both going to be in the same IP subnet. I'm using a different IP subnet for NFS and for iSCSI. So the NFS subnet will be used for NFS, the iSCSI subnet will be used for iSCSI. So I don't need to select anything here, and I can click on next. Then I'm going to use static IPv4 addresses, And the IP addresses that I'm using for iSCSI, the subnet is 172.23.12. It was .11 for NFS. And for host 1, I'll give it IP address .51, and the subnet mask is 255.255.255.0. And then for host 2, I'm going to give it the next available, which is .52. And again, the subnet mask is the same. And again, I don't want my traffic to be going via a router for storage, so I don't need to configure anything for the gateway. And I click on next, and then click on finish. So that is my IP address configured for the first uplink for iSCSI. I also need to configure an IP address on the second uplink on both hosts as well. So that was on SAN B. So I right click on SAN B, add VMkernel adapters, click on attached hosts, select both of my hosts and click on OK, and then click on next. And then I don't need to configure anything on this page. I click on next. I'm going to use static IPv4 settings. And for host 1, I'm going to give it an IP address in the same IP subnet again. So that is 172.23.12. And for the second uplink, for the first uplink, I give it 51. For the second uplink, I'll give it 151. Subnet mask of 255.255.255.0. And then for host 2, I'm going to give it 152 and the same subnet mask again. So for this example, I'm using the same IP subnet for both the Fabric A path and for the Fabric B path as well. If you wanted to, you could use 2 different IP subnets there. Doesn't really matter which way you do it. They'll both work fine. Okay, I then click on next and click on finish to complete. And once this is done, my topology is going to be updated. So I can look at SAN A and I can see there's my VMkernel ports for SAN A, which is using uplink 1. And I can see there's my VMkernel ports, which is using uplink 2. So that's the same as what we'd configured for NFS so far, right? Well, for iSCSI, you need to do an additional step over and above what you do with NFS, and that is adding the iSCSI software adapters. That's configured on the hosts, so I need to go to the hosts and clusters page here in the vSphere client. So I'll click on that. I'll expand my folder here, and I can see there is host 1 and there is host 2. So I'll click on host 1, and then I'm going to click on configure here, and I want to add a storage adapter. So for iSCSI, you can either use a specialized hardware iSCSI adapter, so that's an actual hardware NIC that you need to buy from a manufacturer. If you're going to just use a normal network card in your host, which is common, you configure an iSCSI software adapter. So I've got host 1 selected, I've gone to configure and storage adapters, and I'm going to add a software adapter. And I'm adding a software iSCSI adapter. And then click on OK. So nothing to configure there, you just say that you are adding it. And then I can see that that is now completed, and I can see that I've got an iSCSI software adapter available. So I will click on that, and then click on the network port binding, and click on add. And then I want to select both SAN A and SAN B. So what I'm doing here is I'm adding an iSCSI software adapter that is going to be used for my iSCSI traffic, and it's able to use both paths. So it's going to use the VMkernel port that's going through the SAN A side. It can also use the VMkernel port that is being used for the SAN B side. So I've got a single iSCSI software adapter. I can configure my multipathing on here, so I can say whether I want to load balance over both paths or if I want to prefer one path. So that is all done, and I can click on OK. And once that is done, it's going to give me this notification here that a rescan is recommended. So I will click on rescan adapter. That will rescan it, and now everything is good. So right now, I have got my iSCSI software adapter configured on the host. It's configured that it can use both paths. I still don't have the storage configured yet, so I would need to configure my storage on the storage system and connect to it from the host. I'll show you how to do that in the next lecture. So I've done my iSCSI software adapter for my first host. I need to do it for the second host as well. So I will click on the second host, and I'm on the storage adapters page here. Click on Add Software Adapter, and then click on OK. Nothing to configure. Wait for that to complete. And then when it is completed, I will click on the software adapter. And then on the network port binding tab, I will click on Add. And again, I'm going to add both my port groups for SAN A and SAN B and click on OK. And when this is done, again, I'll click on the Rescan Adapter button. Okay, so that was the whole thing. I'll see you in the next lecture where we'll actually configure the storage. Thanks for watching. Before you go, I'm excited to let you know about my new ONTAP 9 Storage Complete course. It's available this week for special discount launch pricing, but the cart closes this Friday, the 18th October. I'll put a link at the top of the description below where you can find out all the details.